Hi, just something about myself. My name is Artur. I'm a software engineer working at Auth0, where we try to make the authentication and authorization as easy as possible for the developers. So think of it in a way that, like 20 years ago, like everyone was writing its own, his own database, right? And like each company has its own database, and at some point, no one was writing, no one other than some specialized companies was writing a new database because it didn't make sense. Like those problems can be solved properly once and improved. It doesn't make sense to reinvent the wheel, right? That's we like all the developers or engineers, they like to work on new problems, trying to solve new solutions, so we don't want to reinvent the wheel. So I work on the service management and multi-tenancy, so it's not it's not correct core product like the core authentication authorization, but I think I knew some stuff related to it, so maybe I can share it with you. So what this talk is about and why. So just how many of you implemented authentication and authorization? Yeah, I think like few people already did. So how many of you had problems with implementing it properly? Yeah, it can get really, I did it myself like few times, pretty bad. So this is the problem I want to solve. Like, really, we have a user, right? And the user wants to have access to some resource. It can be like a photo. It can be API that enables him to make a bank transfer. It can be like any kind of functionality of piece of data. So the problem is quite simple. It's just like the user wants to make that action, and we just need to make sure that this specific user makes that action. But if you consider that this user can be on some private network, like in some enterprise company, or this user can want to perform that operation through public internet. We have like many types of devices. We have many protocols now to implement, and the complexity of that problem is based on the number of possible solutions that we want to apply. It can get really messy, but the problem is like extremely simple. So to help tackle this problem, we can just break it down to two pieces. So first one is the authentication one. This is like really basic thing. What authentication is about is just who a user is. We want to know, like in practice, we have like if we have a server, the request is coming in, we want to know who's performing that request. It's just like who a user is. So we need to determine that the user that claims to be that specific person or machine. Now we have like APIs, IoT, everything. So we need to make sure that that specific user is the one that it claimed to be. And the user mostly need to validate it first through some like credential validations, answer some like security questions, maybe facial recognition or biometrics recognition, and it's usually done before the authorization part. So the second piece of the problem, authorization. So what is authorization really? Authorization is about what the user has access to. So it's all about the permissions, maybe some roles. It's the process where we verify that this specific user have access to some specific resource. So the resource as I mentioned before, can be some photo, some private photo, or on a social network, or the resource can be an API to perform a bank transaction, and the resource can be some like secret financial, like really high, really important financial documents at the company X, where just a subset of the users can really access that important financial informations that are not public to anyone else. So the authorization is all about what the user has access to, and it's really important to break down this first initial problem to two sub-problems to try tackle it properly further. So this is an example how the basic web scenario for the authentication worked for many years. It's just a pattern that's used for over 2 decades. So how many of you just used regular server-based authentication, where the user is just first log in with username, password, and then the server is executing some logic, checks the credentials with some storage, and just returns the session ID. For the given session. So the browser basically just keeps the session, and every other request that the user performs contains this session ID, so it's authenticated on the server side. So how many of you implemented something or work with something like that? So this is here like for decades now, and it's probably not going away. Probably it's really good approach for some initial implementation, and it's used by top companies still that are just rendering their web pages and using like server-side authentication. So I just wanted to start with just this simple example and introduce you probably a library that you already know. It's quite popular and it's quite easy to use. So PassportJS. PassportJS is just an authentication middleware for Node.js. It works with some frameworks like Express.js, I think also with Koa and some similar ones. But it's just like a simple middleware. But it's very useful even for this simple use case or simple strategy that we had before. So it abstracts the logic of the authentication away from our app. It helps us just to reuse some proven patterns and don't make like the same mistakes again. So we can use just the PassportJS to implement the basic server-side authentication quite easily. And let's just take a look at some code first. So PassportJS is based on the strategies. It helps you implement some specific authentication strategies to use the basic like username, password, server-side authentication. We can use just the Passport local package that contains the strategy for this specific flow. It's quite simple. Basically, we just need to provide an implementation for the function that pass the username, password, and a callback. So then we provide our own logic to, for example, check if the user is in our specific storage that we use in our Mongo or MySQL, Postgres, whatever. If the credentials that the user are passing are proper, if the password is matching the one that we store. So we need to add some validation, we need to add some error handling, but eventually we just call the callback with some error messages, or we just pass, in case of the success, we pass the user object. And I have a simple example we can just run and take a look how it works in practice. So just give me a second, I'll try to switch the presentation. Okay, and just let me know if you can see the code in the back. Or if anyone, like if there's someone that doesn't see the code, just raise your hand and I'll just try to, okay, there's at least 2 people or more, so I'll try to zoom it even more. Come on. So this is based on just the default Express.js 4 example. That's part of the examples. In Express.js, you can fork it by yourself. You can play with it and use it. I just want to just showcase it and tell you about like few problems that we want to solve here and what can be improved. So we have some basic dependencies like Express, Passport lockout, which is the strategy for username and password. We have some required for the database. In our case, it's just a simple array that contains users with strongly encrypted passwords in the storage. And it's just to showcase the functionality. So there's no like real storage behind it. You can plug it. You can plug in anything you want to make it work. But this should help us to demo the PassportJS with the basic auth, local auth. So what Passport, like how Passport middleware works, it basically we provide what kind of strategies do we use. The strategies are provided in separate packages, so there are like many strategies available. I'll talk about it like a little bit later. And in our case, as I mentioned before, we have the basic like local strategy that is based on the username, password, and the callback. We just do some basic validation here and execute the find by username function that just returns our user from the array, so we can return the user object to the middleware, so the middleware can add that user to our request at some point of execution. In this specific strategy, we also need to provide some implementation for the serialized user function and the serialized user function. So in the basic auth, like the Express.js maintains its own session. So the user is serialized to the session storage on the server side, and we just need to provide the implementation for that part. Here, it's just some like boilerplate to create the Express app and add some login templates. And as I mentioned before, we need to use the Express session to support the session functionality, and in the end, just initialize the PassportJS and Passport sessions. So we have just few default routes. The home one, like login, that will be responsible for rendering the login screen, the login for passing the credentials with a post request, and logout just for cleaning up the session, logging out the user, and the profile one that is responsible for providing the user data once the user is logged in. So the app is already up and running. We can just play a little bit with it. So we have the main root. We can log in. The profile shouldn't be available anymore. Yeah, it's just redirecting to login because like no one is logged in and no one is authenticated. So we can use our user from our database with a super secret password. And once the user was authenticated, as I previously showed on the diagram, the cookie with the session was returned to the browser. So we have the cookie here that it's basically keeping our browser logged in as a given user. And we can view the profile with the user data now. So once the cookie is removed, no one is logged in anymore. So this is like the most basic use case that's used in many applications still. And as you can see with Express, it's really fairly easy to implement. There are few details you can add, but it helps you to get up to speed and running really fast. So there are a few problems with this implementation, and we can talk about it in a second. So one problem, for example, is now, of course, like the password is not stored properly. We're just using localhost. We don't use any secure way of transferring the credentials through network, but we're just working locally now. But one of the big problems is that basically the session is kept on server side. So whenever the server is restarted, like it basically removes all the sessions. Like the sessions are like just removed. So if I restart the server, I'll start the server again. Like the user is not logged in anymore. So yeah, let's move to the next slide where we can talk about like few improvements. So some basic improvements, and having said that, you can use this approach like with a pretty good success, like really far away. If you're building a fairly complex application with just those basic requirements, I think like I've seen a company that was built up to almost 200 million users on that kind of pattern. So like there are many companies, there are many web apps that are just using this basic flow, and it's good enough for them. But what can be improved here? Of course, we want to have proper password strength control. Like we shouldn't allow our users to use some really weak passwords that can be so to prevent like some simple attacks, brute force attacks. We of course would like to store the password with some proper hashing algorithm using bcrypt and like one salt per user. Of course, we should use HTTPS and mark cookies as secure, so they can only be transferred through HTTPS to prevent like middle attack when users are in some public unprotected networks, like just working at Starbucks, and someone is stealing their credentials. So of course, same origin policy also can help to prevent the request from the different origin to our app. And as I mentioned before, we have the problem with the session being stored in one server. So this can be easily mitigated, and I've also used it with the success. We can just spin up a new cluster, like a Redis cluster or some key value cluster, to keep the session separately, have some backup mechanism for them, and just like move the sessions away from the one server, so we can have 100 Express servers, and they can just use this key value store as a session storage, and that should work to some point. We can also use things like multi-factor authentication to either improve the security of the accounts. So, yep. As I've asked before, I've seen like that many of you use this flow. So, how many of you are working on apps or with companies that are still like using this server-side basic authentication flow? Can you raise your hand again? So quite few of you, and I mean that makes perfect sense in many cases, but the problem here at some point can be this. So that approach was successful for many years, as I mentioned, but meanwhile the industry moved way forward. So for the consumer web, we have now social providers like Facebook, Google, Twitter, LinkedIn, GitHub, and hundreds more. We have new protocols like OpenID Connect and Auth 2 for authorization and for basically resource access federation. So let's say your Facebook account want to have access to your Gmail account, so it can send invites to your friends automatically to Gmail, and this is introducing some additional level of complexity within the authorization space. So we have a new protocol for that. And in the enterprise, like so how many of you like work more on like consumer apps for just like regular users, not like enterprise customers? Or okay, and how many of you work for enterprises that like just use some Active Directory for managing users? Okay, so for the consumer space, basically, for the enterprise, basically what happened, it began that every enterprise that had their own internal network. They have some Active Directory to manage the users. It was super simple. Everything was fine until someone at some point decided, okay, but the employee from our company want to have access to your company resources, and we have a separate Active Directories in separate private networks. What to do? So we invented a new protocol. It's called SAML, and also in the enterprise world, like the number of use cases and the number of potential authentication and authorization scenarios increased a lot. Also, we introduced new functionalities to improve the security, like MFA. We want to have some like role-based access control, and then there is this another dimension. So, like previously, everything works. The web page was rendered, the server-side authentication worked, and then someone came up with an idea, let's throw some JavaScript into the browser and break everything. So React, Angular, SPAs now basically are not are working kind of like separately out of the server side, and we have new devices, new ways to access our data from new platforms like Android and iOS. We have a new architectures on the backend to have microservices, having like hundreds of services that want to access, to have authenticated requests, and we have patterns like API gateways. So everything got more and more complex, and this is actually why PassportJS can be useful. So now PassportJS contains over 500 strategies, and for most of the scenarios I described, there is some PassportJS strategy. They are fairly well documented. They are fairly well reviewed. I think there is high certainty that the quality of those strategies is high. So I would say that you can implement your server-side authentication without PassportJS, and that's fine. But at some point, you may end up in a place where you want to introduce new strategies, support new functionalities, and this is the big selling point for the PassportJS. So, as I showed before, adding new strategies is fairly simple, and extending your authentication of your app can be abstracted away, so you don't need to think about it. It should be also easier to test, and it doesn't. In many cases, what I've seen is that the authentication authorization code also can spawn to other places of the system, and this can be pretty awful. That logic lives somewhere else, and it can cause some really serious security issues. So having that in library or having that abstracted away is very useful, prevents potential problems. And one more concept I want to talk about a little bit today is JSON Web Tokens. So I'm not sure how much time do I have, like 5-10 minutes? Whatever, okay, awesome. So JSON Web Tokens. This is in the security space. It's a fairly new standard. It's a open standard that defines a compact way to securely transmit information between parties. So securely transmit claims between parties. It's used mostly, I would say, like it's used mostly for authorization use cases. And the information in a token can be verified and trusted because it's digitally signed always, if it's if the implementation is proper. And the JVS can be signed using a secret and HMASC algorithm, or a public-private key using the RSA, basically. So it's mostly used and intended to be used in RESTful endpoint without session, where we don't have this traditional idea of server-side session. So let's just take a look a little bit how the JSON Web Token is constructed. It has 3 parts: the header, payload, and the verify signature. So the header just tells us what kind of token it is. In this case, it's just JWT. And then we have the signing algorithm that is being used. The payload data is the data that with the claims of the token. So this is also the data we can actually provide. We can put there any kind of data we want, any kind of claim, any kind of permissions. We just need to remember that if this token is not signed with RSA or public-private key, it can be the data can be accessed by deserialization. So just depending on the use case, consider what kind of data you want to put there. And the last part is the signature. And basically the signatures used to verify the message wasn't changed in the token. So this, like, let's say, established approach worked for many use cases for many years. And why would you like to switch from server-side server-based authentication to this token-based authentication authorization scenario? So for the most common use case for using JWT is for the authorization. So once the user is logged in and we create the token, each subsequent request will include the JWT, and specific route can retrieve the data it needs to perform the authentication authorization, or in our case the middleware can perform authentication, and then we can write or describe our authorization scenario. And it's easier to use with the single sign-on scenarios, where basically you create a token with some claims that can be used across like different domains. So it's way easier to implement like a SO with it. And two more features that are, in my opinion, really important: that the token is stateless, so it's easier. It's way easier to scale your solution. And the token contains all the information to identify the user. So we don't need to scale our session or design our session. We just basically focus on the logic implementation based on the data the token is providing us. So for the performance side, this is again related to this approach where you have like some single source of truth, some sessions, so some like one place where you just need to validate your request against. So for the performance, basically that means we don't need that single point of authentication anymore. We just need to calculate the HMAC SHA to validate the token is parsed correctly, and we can get the content out of the token. So just quickly, I'm not sure how much time we have, like not much. Okay, so just to go quickly, I don't want to dive into much details with a second demo example. This is just a basic scenario or basic strategy for implementing the JWT tokens authentication with PassportJS. So again, there is just Passport JWT strategy. Additionally, we have in that strategy a flow to extract the JWT token. So we create just the options object that contains contains the algorithm how the token should be extracted from the request. We need to pass a secret or key, an issuer, our audience, and with those options, basically, this strategy can get our token from the request and return the user objects and inject it to the request. So then when we just for a given, okay, I don't have an arrow here. So then when we have a specific route where we're trying to restrict the access to the profile of the user, we just need to pass that it's using the passport authenticate with the JWT, and we have access on the request user to the user profile that can be available in the token. I think in this example still there is just like some call or lookup in the users find one, but you can also work your way around without doing additional like requests or queries to your storage, just using the data from the token. So yep, that are the basics, and here are a few links if you want to reach out to me, ask any questions, or just get into the contact. I have also some links related to the libraries and the JWT IO link, which describes more details about the token and use cases and when and where it should be used and how. So one thing I think I forgot about is that a really important factor also for the JWT is the usage and the support. It basically has really well documented and written libraries for any language. It's a standard that's established and used by really big and by quite successful companies. And yeah, I encourage you to just dive deeper into that topic and just explore. So I don't know if we have time for questions.
Yeah, please give a big round of applause to Artur. Is there any questions?
You mentioned like the positive sides of using JWT tokens. What are the downsides of actually using it?
Yeah, I know that this question will always be in the audience. So there are some security concerns also just about the tokens, but I don't want to like dive too much into the details. But in my opinion, the biggest downside is just that you shouldn't use more complex, like you shouldn't use more complex tool that you need. So if the server side, like basic server side authentication works for you, if simple like session ID token, session ID storage works for you, making your architecture implementation more complex just to have like JWT doesn't probably make sense. But as I mentioned, I work with a company that actually tries to solve that problem. So we try to make it simple for developers. And I can follow up on more like security related issues after the.
What about the size? The size of the.
Oh yeah, the size of the account has also some limits, so you need to take that into consideration. Of course, that's a good point. And for some really complex policies or really complex claims that you would like to put in token, that can be a problem. That's true.
The one last question. Okay, so you are closest to me.
Okay, thanks. Great talk. But I've got a question about what we should do actually when that payload we decide to change.
Okay, so basically in that case, which like the token has some like life cycle, and when you want to change the payload, you just need to generate new token, and you need to finish the life cycle of the old one.
Okay, so basically that token will be invalid.
Yeah.
Okay.
Yeah. So you just need to create a new token with the new claims.
Thanks.
Thanks a lot, Artur.